if the wavelength of the first line of the Balmer series is 6561 angstrom and the wavelength of the second line of the series should be. So Balmer series, for the first Balmer series, there is a empirical formula. Balmer series always ends at state 2. N2 can be 3, 4, 5, goes on up to infinity. So the empirical formula for Balmer series, empirical formula, general we are all aware of. Wave number is 1 by lambda equal to Rydberg constant 1 by n1 square minus 1 by n2 square. For Balmer series it is n1 is fixed, no. So 1 by lambda is equal to r into 1 by 2 square minus 1 by n2 square. This is a fixed empirical formula for Balmer series. For Lyman series it is 1 by 1 square only. Okay. Now for the first line, n2 should be 3 and lambda 1 is 6561 angstrom. That is given. That is given now. However, we will write it first. 1 by lambda 1 is equal to r into 1 by 2 square minus 1 by 3 square. So this is r into, this is 4, this is 9, 36 is a common denominator. So this is 9 minus 4. So 1 by lambda 1 is 5r by 36 implies lambda 1 is 36 by 5r, equation 1. Lambda 1, of course we know the value, that we will substitute at the end. Next, for the second line of the Balmer series. For the second line of Balmer series, n2 should be 4, correct? See, this is how, this is n equal to 1, this is n is equal to 2. So this is the first line of the Balmer series, n equal to 3. n equal to 4 is the second line of the Balmer series, where the transition of the electron from the higher orbit ends at the second orbit itself. This light, whatever the radiation given out, can be viewed by us also, can be seen by us, because Balmer series lies in visible region of the electromagnetic spectrum. So these are the colors we can visualize, we can see. In Lyman series it occurs in ultraviolet region, whereas the others, Paschen, Brackett and Fund series, they lie in infrared region, that we cannot see. Now for the second line, same 1 by lambda 2 r into 1 by 2 square minus 1 by 4 square. So r into common denominator is 16. This is 4. 4 minus 1. So 1 by lambda 2 is 3r by 16 implies lambda 2 is 16 by 3r, equation 2. Now I need to calculate lambda 2. So lambda 2 by lambda 1 is equal to lambda 2 by lambda 1. I have to calculate now. That is lambda 2 is 16 by 3r and lambda 1 is 36 by 5r. So r cancel. Then it is 80 by 108. 16 5s are 36 3s are 108. So is it possible with the 24? Not quite. 4 20s are 4 27s are. So lambda 2 is 20 into 20 by 27 lambda 1, which is 20 by 27 into 6561 angstrom. 561 angstrom. So calculating this, I think we can try with the 27 here. 27 2s are 54, 11, 116. Then we have to multiply. Okay, that we will see. 27 2s are then 116. 116, 27 3s are 81, 108, 4s are. 4s are. Then 8 remains, 81, 3s are angstroms. So 243 double, 486, 10, 4860 angstrom is the value of lambda 2, which happens to be option C. So option C is the right answer.